Today we are going to look at projectile. A projectile is any object that is falling or moving freely under the influence of gravity and air resistance alone as the only forces acting on the body. So a projectile is any object or a body that is launched into the space, launched into the air, and is being acted upon only by the force of gravity and air resistance. But when we are looking at calculations under projectile, the influence of air resistance is taken as negligible. So we don't reckon air resistance in our calculation. The only force that affects a projectile under our calculation is the force of what? Gravity. A projectile is any object falling or moving freely under the influence of gravity and air resistance only as the force acting on it. So when a body is thrown into the air and the body is moving freely under gravity, that body is a projectile. We are going to talk about the trajectory of a projectile. What is the trajectory of a projectile? It is the path that a projectile follows during its travel. So we say that the trajectory of a projectile, we say this is the path of a projectile during its travel. Most trajectories of projectiles in real life, they are usually in the shape of a parabola. The trajectory of most projectiles are in a parabolic shape. We say that the trajectory of most projectiles in nature, they are usually what? Parabola. And this is basically a shape like this. A shape in this form. This is a parabolic trajectory. A parabolic trajectory, like when we take a stone and throw it, move down, release a catapult, a stone from a catapult, it goes down in a parabolic shape. We throw a javelin, it goes in that parabolic shape. Throw of a shot put, it goes in that parabolic shape. This is basically the shape of most projectile in nature. Examples of projectile in life. A stone that is released from a given height as it's falling is a projectile. When we throw a stone into the air, it's a projectile. When a bullet is released from a gun, that bullet starts moving, it's a projectile. The throwing of javelin, when javelin is thrown in sport, that javelin is an example of a projectile. The throwing of shot put in sport, when we throw shot put in sport, that shot put is also an example of a projectile. The throwing of discus in sport, hammer in sport, the release of missiles in war, in warfare, is an example of what? Projectile. The release of bombs, even from a plane or helicopter thrown as the bomb is moving, is a projectile. Release of bullet from gun, release of catapult is a projectile. Even when you throw a dart, it's a projectile. What about the spear? When you throw a spear in hunting, All these are examples of projectile. We are going to look at some terms that we use in the study of projectile. Probably I would like to use first a parabolic trajectory of a projectile to define some of the terms used in a projectile. Let me take this shape and this is point A. I'll take at the middle here. I'll take this is point B. And I'll take this point as point C. And the projectile is released from this point. This is the initial velocity of the projectile release. And this direction here, I'll take it as what? Theta. Theta. I'm going to use this parabolic projectile in defining most of the terms used in projectile. Terms used in projectile. One, I'll talk about the projection point. My projection point, I'll take it as point A here. What is the projection point? The projection point is the point where the projectile is released into the air or into space. This point is referred to as the projection point. The point at which the projectile is released into space or into air is referred to as the projection point. Then I'll talk about the projection plane. What is the projection plane? The projection plane is an horizontal line. An horizontal line from the point of projection, or what we call from the projection point, an horizontal line through the point of projection is referred to as well the projection plane, which I can represent with this outline AC down. Line AC. Line AC can be referred to as our what? Our projection plane. An horizontal line from the point of projection down is called our projection plane. I'm going to talk about the maximum height. The maximum height. I want to use capital H to represent the maximum height. Now, what is the maximum height? The maximum height of the projectile is the maximum vertical distance traveled by the projectile measured from the projection plane. The maximum vertical distance traveled. Look at our projection plane here. This is the maximum vertical distance traveled from the projection plane, measured from the projection plane, is referred to as the maximum height. That is our maximum height, H. Then we are going to talk about the range. The range. The range of a projectile is the maximum horizontal distance traveled by the projectile. So the range of a projectile is the maximum horizontal distance traveled by the projectile. It can be given as what? The distance from the projection point to the point horizontally where it hits the projection plane again. So we can say that our range here, range, can be given as what? Line AC. So the distance AC is given as the range of the projectile here now, which is the maximum horizontal distance traveled by the projectile. Then we have to define another term called the time of flight. The time of flight. I want to use capital T to represent the time of flight. Capital T to represent the time of flight. The time of flight is the total time taken by a projectile during its journey. We say that the total time taken by a projectile during its journey is referred to as the time of flight. From the time it was released from its point of projection up till the time it gets back to the ground again is referred to as what? The time of flight. Then we are going to look at another term, the projection angle or angle of projection. Angle of projection. I'm going to indicate it with theta in my diagram here. Theta, the angle of projection is theta here. What is the angle of projection? It is the angle between the projection plane and the initial direction of the projectile when released from the projection point. We say that the angle of projection is the angle between the projection plane and the initial direction of the projectile when released from the projection point. We refer to that as well, the angle of projection. Then we have time to reach the maximum height. The time to reach the maximum height, it is the time taken from the projection point to the maximum height. The time to reach the maximum height is the time taken from the projection point to the maximum height. Here is the maximum height point. The maximum what? Maximum height point. That is the maximum height point. So the time to move from A to B here is called the time to reach the maximum height. So you can see that the time to reach the maximum height and the time it will take from the maximum height back to the ground, they are usually the same. They are usually the same time. So you now have small t here also to reach this point. For projectile that follows what? A parabolic shape. For projectiles that follows a parabolic shape. So it means that for projectile that follows a parabolic shape, the time of flight, capital T, will be equal to T plus T, small t plus small t. And that will give us what? 2 small t.